Good morning, everyone. Today we are going to look at elements in period 3. Now, if you look at the periodic table, going across from left to right, that's period 1, period 2, and period 3 in the yellow boxes. So elements in period 3 are sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Magnesium is used in lighters, aluminium is used in cans, phosphorus is used in fireworks, and sulfur is used in fungicides. Fungicides is a type of poison for fungi. Alright, we're going to look at two things. Firstly, we're going to look at the physical properties of elements. Secondly, we're going to look at the chemical properties of the oxides of elements of period 3. Okay, let's look at physical properties first. First of all, as we go from left to right of the period, you can see the size of atom decreases. Now, why is this so? As we go across period 3, the number of protons increases. So, sodium has 11 protons, magnesium has 12 protons, and it increases. Argon atom has 18 protons. Now, the more protons it has in the nucleus, that means the more positive charge there are in the nucleus. So as we go across period 3, the number of protons increases, so the positive charge of the nucleus increases. And therefore, the nucleus attraction on the electrons becomes stronger. Positive charge attracts the negative electrons stronger. So the stronger the attraction force of the nucleus on the new electrons, the smaller the atom size would be. As we go across period 3 also, the electronegativity increases. So you look, electronegativity, as you go across the period, electronegativity increases. Now, why is this so? Electronegativity means the ability of the atom to become a negative ion. So, if the number of protons increases from 11 protons to 18 protons in the nucleus, that means the attraction force of the nucleus on electrons becomes stronger. Imagine 11 people pulling electrons and 18 people pulling electrons. Of course, 18 people pulling electrons will be stronger. So stronger force of attraction. So stronger force attraction means the nucleus has a stronger tendency to attract electrons into the atom. So when there is an extra electron, that means it becomes a negative ion. So electronegativity becomes stronger as we go across the period. Okay, now we are going to look at the chemical properties of the oxides of period 3 elements. Now these are oxides. Just now what we looked at is the element itself, Na, Mg, Al, and so on. Now we want to look at the oxides. Oxides means sodium oxide, magnesium oxide, aluminium oxide, silicon 4 oxide, phosphorus pentoxide, sulfur dioxide, and dichlorine heptoside. Di means 2, so there are 2 chlorines. And hept, H-E-P-T means 7, so there are 7 oxygens, dichlorine heptoside. So we want to look at the chemical properties of oxides. Now, as we go across the period from left to right, their properties changes from basic oxide, basic, or you are more familiar with the word alkaline, all right? It changes to amphoteric oxide. Amphoteric oxide means it has both basic and acidic properties. Okay, and then it changes to acidic oxide. So from base to acid. Okay, so if you look at the experiment, you can see, alright, the first experiment, we want to react period 3 oxides with water, and then we want to see their pH. So sodium oxide, okay, sodium oxide powder you put into water, it will dissolve to become a colorless solution. And what do you think? If it is a base, so the pH value would be above 7, isn't it? Base is above 7. Alkaline, above 7 pH. Okay, so the pH value 1 to 6 is acidic, 7 is neutral, 8 to 14 is alkaline or basic. Alright, so if this is sodium oxide, basic oxide, so you would say that the pH value will be above 7. Above 7, okay, above 7. So, and you're right. Okay, the pH value for sodium oxide is between 13 and 14. Now we come to magnesium oxide. Magnesium oxide, so it should be less base than sodium oxide. So the pH value would be around 8 to 9. Okay, aluminium oxide, it will be less basic. Okay, but aluminium oxide does not dissolve in water. Sometimes their pH value will be different lah, because it can appear in many forms, aluminium oxide. Okay, not to worry, we look at acidic oxide now. Acidic oxide, so sulfur dioxide would be an acidic oxide. Okay, acidic, so acidic pH value would be below 7. Alright, in this case it will be around 2 to 3. Okay, 2 to 3. Alright, now we want to look at their reactions with sodium hydroxide and nitric acid. Sodium hydroxide is an alkali. Nitric acid is an acid. So base can only react with acid. Base cannot react with base or alkali. Base and alkali is more or less the same. In another chapter, we will learn more about acid and bases. Okay, so remember, base and base cannot react. Boy and boy, no reaction. Okay, boy and girl only got reaction. Okay, this one, amphoteric oxide. Amphoteric oxide has both basic and alkaline properties. Sorry, basic and acidic properties. So it can react with both. Okay, so we say this is, it is like aqua lah. Can react with base, can also react with acid. Can react with boy, can also react with girl. Okay, this one, acidic oxides. Acidic oxides, acid ma, they are acidic ma. So they cannot react with acid. Okay, girl cannot react with girl. Alright, so acidic oxide, acid react with sodium hydroxide. Okay, so these are all the properties of the oxides of period 3 elements. Now, after watching this video, I want you to write some notes, and after that, you do the lab report for experiment 4.2, and after that, you also do test yourself 4.6. Okay, just one more thing before we finish. So you can see this silicon here. Okay, this is semi-metal. Now all these are metals: sodium, magnesium, aluminium, they are metals. Okay, silicon is semi-metal, and phosphorus, sulfur, chlorine, argon, they are non-metals. Now semi-metal, or another word for semi-metal is metalloid. what are the uses for semi-metals? Because they are weak conductors of electricity, okay, but when it's high temperature, they become good electrical conductors. So they can be used to make microchips for the computer and to make microchips for mobile phones. Okay, so that's all for today. Thank you.